We're going to talk about a little bit more, about object-oriented Python and stuff that is related to what we're going to be using here. So I'm going to go ahead and just start off by sharing do code. There we go. Awesome. Bring chat up. Cool. Cool. Sweet. So last time we talked a little bit about the decorators that we wanted to use for um, adding the properties and stuff. Um, I think maybe the easier way is to do it with just the property function, which is what we left off with. But I did want to talk more about decorators because we will be using them both here and in the future as we hook up stuff in Flask, especially next phase. So just a quick like whirlwind tour of um, decorators, what they are and how we're going to use them. And again, anytime you want to stop me, ask a question, uh, feel free to do so, even if it's not directly related to the stuff we're talking about here. That's what we're here for. So yeah, in Python, like everything else, functions are objects, first class functions, um, which means that we can pass them around just like we did in JavaScript. We can pass them as callback functions. We can call them and return stuff. So let's create a higher order function that does that. So I was going to make a couple little, I don't think I need that. I'm just going to import or not import, write a couple little functions. So if we're still doing pet stuff, let's do walk. Take pet as a pet walked. Pet walked. Yeah. If we want to feed the pets, print for pet is fed. So we just got these two normal functions. We're just taking strings right now. So if we do walk, let me run our thing here, and this is just running in. Yeah, let's run that decorator example. Python. So great, those run. So if we want to do a higher order function that takes this one of these functions as an argument, let's say we're going to define do dog stuff. Yeah, that's great. It's going to take in a callback function. We can call it func. We can call it callback. Um, yeah, we'll call it fn for now. So this is going to take a function, and we're just going to call that function with dog. We'll say. So every time we pass a function to that, it's going to do it with dog as an argument. So we can call it. Let's do this. Let's do dog stuff with walk. And so walk is our actual function here. We can do dog stuff with feed. Oops. We could even do dog stuff with built-in stuff. So we can do it with print. Easy. So each one of these, this is the function it's calling, do dog stuff. That function takes a function as an argument. So it's just like, adding an event listener or something, or setting something to map or sort. We're just sending a function to this function here. And then inside that function, we're calling it. We can do other stuff, right? We can do whatever we want before or after it. But the only thing eventually we're going to be calling this function in here. So I expect to see dog walked, dog fed, and then they'll just print out dog, because when we call dog stuff, we are passing it a function, and then it's going to call that function with the argument in there. So let's see if that does what I think it does. Yeah, great. If I can get rid of those so we can see more clearly. Cool. So calling walk, calling fid, calling print. If we wanted to make another one that's just like do ostrich stuff, we could have that in there. We could pass the thing as a second argument here. So we could say, pet. Of course, that wouldn't be dog stuff anymore, but you get the idea. And so this is what kind of not or object-oriented programming looks like, right? Because we have our functions, we're throwing data at our functions instead of having a clump of data and then calling methods on it. Yeah, cool. So we did that. So we can have this. This is kind of where it gets a little bit trickier, I guess. Let me undo those changes. Cool. So we can not only take functions as an argument, right? We can also return a function. So if we wanted to, let's get this for a second. Say we want to get a get a walker. Let's do that. Def and yeah. So I'm gonna take this and define it inside. In fact, how about that? So this is part of this function. We can define functions inside the functions. And what we're going to do is just return that. So this is a function that creates a function for a pet. So if we say walker equals create walker, if we print out walker, see that. That's a function. Cool. And now we can call that function because we just created it. So we can say walker with a dog. Hardly know her. Dog walked. Great. And cool thing about like making a generator or a factory like this, this is one of those patterns I was talking about, factory pattern, is we can take in something. Oops, sorry, pet here. My bad. And we can just call, let's call it pet. So we can create a walker for a particular pet. And then when we call that, we know it's going to be walker. We know it's going to be for that particular pet that we created it for. So we can create walkers for whatever we want. So this tells us that we can create higher order functions that take in functions as arguments. They can call functions inside. They can return functions, and they can add context to these functions that we're creating. Cool. That's all background. Yeah, get rid of all those. This should be pretty familiar to you by now. If you have questions, please speak up. Cool. So coupon calculator. All right. Years, I guess. So what does this have to do with decorators? Like I said yesterday, a decorator is a higher order function that takes a function that's after it. So here's our thing, and here's our function that does stuff we're defining afterwards. So in general, a decorator is going to, this is actually a function we're going to define. And then it's going to take this next function as an argument and then do stuff with it. So let's look at an example. Yeah, sure, why not? Cool. So let's create a decorator. Great, we did it. It's going to take in our function. We'll just call it, we'll call it func. And so a decorator, it takes an argument as a function. We did that. We're going to define some function inside it, like we did with the walker, and we're going to return it so we can use it. So what do we want this to do? Coupon calculator. Oh, I have my thing over here. Great, that's helpful. So I want to define something called, in this case, it's going to report price. Right now I'm going off of notes. So this function is going to take in a price, and right now I'm just going to set it to whatever, 35 bucks. And I'm going to say, here's my final price. And that's going to equal, we're just going to call this function on our price. Let me set this is a variable up here. Equals 35. Now we can use some string stuff here. Right this time. Cool. I'll take that instead of making 35 magic number in there. I'm going to call that function on the price. Great. So this is the function that we're going to be returning, right? So let me actually print out what the discounted price is here. I don't need that much help. Final price. Yeah, sure. That's going to be our final price. Great. So this function, again, is going to take a function in. It's going to create a new function inside here that's going to print the initial price and the final price. Then we're going to return that function. So now we can call this coupon calculator function, and it will get us this function. So we say calc equals coupon calculator. And now we need a function. So I'm going to write another little function up here. Def half off. And this will take a price. And it's going to return divided by 2. Yeah, that'll work. So I'm going to call coupon calculator with this function we just did, half off. And so now I can call calc with, and it'll do, you know what? Yeah, let's do this. So I'm going to call calc, and that should give us 1750, right? Hey, look at that. Yeah, I should do that. Cool. And just doing it with 35 is not super useful. So let's do this. Coupon calculator. No, we want price to be down here. So now the function it's returning takes a price. So we can say 40. Great, works great. So this is just kind of demonstrating how we can pass around all these functions and whatnot. So now let's create this decorator. So we've demonstrated that we can use this function. We've created this function that returns a function. That function is going to take a price and do whatever we tell it to this function here, right? So what does this look like when we make it a decorator? Let's do this. I think I think I'm going to try this. Nope, that's not going to work. How about that? There we go. So half off price divided by 2. I'm going to, oh, I got some weather. I'm going to try to use this as a decorator, and let's see if it works. So we call decorators with the at. Python calls it pi. I find that confusing because pi everything is in Python. Oh, it's raining. Shit. I got a storm in. So I'm going to call this coupon calculator generator as a decorator. Yes. Great. So what are we expecting this to do? So what I expect this to do is wrap this function inside this function. And since it's returning it, the way it works is going to return it as that thing. So if I did everything right and no guarantees, I should be able to call half off with the price. And that should insert all this functionality into this function. Ooh, I'm like 50-50 on this. Let's see. Oh, shit, it worked. All right. Cool. So that was a little magic. What did we do? So essentially, we went all through all this stuff to wind up here. And here we are. You can kind of think of, so let me back up. A decorator is a higher order function. It takes a function as an argument. It does something with that and returns that function. When it returns that function, it's basically replacing the one that you put in. So the easiest way I can think of to think of it is not always a decorator is going to kind of wrap the function that comes after it. So we're saying, oh, this is half off, and we're taking a price. Instead of just returning the price divided by 2, we're doing all this stuff. We're printing stuff out, applying the thing. We could have this do any number of things, but basically the basic thing is that if we write a function like this, we're going to wrap it in whatever the decorator does. And we can kind of see that in the property syntax I used yesterday. We were defining getters and setters, and then using these decorators to basically wrap them in additional functionality that took them and added them to the object and gave us a different syntax to access them with. So this is all, again, kind of background. Writing your own decorators is super cool, and it is one of the best things in Python, I think. Or it is a very cool thing in Python. Don't feel obligated to do that. If you come across a situation where you need to make a higher order function, and just this is already a lot, right? Just keeping the idea of functions as objects that you can pass in and out of functions, calling them inside, returning them, already a lot to keep in your brain. And then like adding this extra magic on top is a lot. So if you find yourself in the situation where you need a higher order function, um, feel free to just do that. If you find yourself in a situation where you want to wrap something around something like that, and you remember how to do it, I have to look it up every single time because I don't do it regularly. But if you become a full-time Python programmer, you'll definitely do it. So play with it, experiment with it. I don't know how much of this is in the curriculum, but there should be some. Yeah, yeah. I think that's enough for decorators, right? Yeah, did all that. Cool. Any what questions do we have about all this stuff right now? I just talked for a while.
So in the yeah, like in the coursework stuff, there was like a quick kind of text resource about decorators, but then it used we went through more specifically using them with like at class method,
Yep, and that's
like
what we're gonna get.
so we're not calling methods on like the instances.
Yeah,
Uh, is that doing the exact same thing? And class method is just kind of like a more generic
yeah,
name for the decorator?
yeah. So that is well, we'll get into that right now. Actually, um, it's a decorator. There are built-in decorators, and that is one of them. And so what that does is it's going to take the stuff the stuff. Let's be the method that you write. So if you do at class method and then define your method, it's going to basically wrap it so that, oh, instead of taking self, it's going to take class, and then it'll run on the class instead of on the
Okay. So it would like in this example here, right? We are wrapping coupon calculator around half off.
yeah,
With the class method one, we're basically wrapping whatever that method is, or we're wrapping
yeah,
like just class name around it,
yeah.
or like, do you understand what I'm saying?
So if we, and I'll do some examples of what class method looks like. Class method, method, right? And this is not at all how it works for real. But basically, we have our class thing. Inside thing, we have whatever method that does stuff, and we want that to do stuff. Um, when we say class method, uh, this is a function, a method that is a higher order function slash decorator that is defined in Python. You don't have to do it yourself. That basically says, take this method that you're defining here, the whatever method, and you're basically going to be like, past this, so it doesn't freak out. It's basically going to define, turn into class method. Um, and then it's going to return this. And in here, it's going to do something like, gosh, how would it do it? So it would take the method and so it knows, find out what class the method belongs to, and then attach the method to the class. And we're good. And then it would probably want to be CLS. And this is where we figure out the class here. So it would find out what class the method belongs to. It would create a function that used that class, and then attach the method to the class, and then call the method. Method class. Sort of, right? So this is kind of what would happen inside. Python is open source. You can look at the code that does this if you want to. But yeah, so basically when you are doing the class method, it's going to wrap it in this magic function. It's not magic. in this function that basically figures out what class it belongs to, rips it out of the instance and inserts it into the class. Does that
Gotcha.
kind of answer what you're asking?
Yeah, that got me like 70% there, and then I have a follow-up. Because it's very clear to me when we do like instance methods, right? Those happen when the instance is initialized.
Yep.
So like is there a event that we can point to for the class method and says like when X the class method happens?
I'm not sure I understand what you're asking. Can you tell me some more?
I think so. Just yeah, like just with the instance methods, there's a very clear event that happens, right? The initialization
Yeah.
happens, and then that you trickle down, and that does your instance methods.
Yeah.
But when we go up the level to higher to the classes, right? We're not like initializing the class, as far as I understand.
Oh
It's
yeah,
kind of
yeah.
just like it is a thing we name.
Um, yeah. So interesting question. Yeah. So when we have our def init here, and it does whatever. So this is called anytime that we create a new whatever, a new thing. So this is going to initialize stuff on my thing, and then when I call methods, it does stuff. Um, I don't think it's super clear because I guess it might become clearer later when we start playing with it more. But basically, everything inside this block here is kind of the like quote unquote initializer for the class itself, because this is, you can think of this as a as kind of a function, right? It's not really, but kind of behaves like it a little bit, where these are just statements. This is just Python that we're putting in here. And so we can also do other Python in here. We can say, of equals 0 and initialize it. We can do some initializing stuff when we declare the class there. Basically, when it creates the class, it's going to be setting up whatever you set there, including all these methods that you're defining. Um, and since like the class isn't instantiated the way that an object of that class is, there's not really an initialization step beyond what's in the declaration. Does that kind of get to where what you're asking?
Yeah, it does, because I'm thinking like in the in this one attributes and methods lab where we're like we have a class of song, and then we're like doing initializing a bunch of songs. Like the class methods are still like happening for each song, so like the count is a simple one. Like every time there's a new song, the count bumps up. And it instructed us to do that as a class method.
Yeah.
So I guess it's more just to be clean and efficient, because you could still do it with an instance method, and just it's still saying every time an instance is initialized.
Which one is that? So just so I can get a.
Yeah, it's just called class attributes and methods lab.
Class attributes and methods lab. Class attributes and methods lab. There we go. Cool. So it's asking us to song counts, problems, add two genres. Yeah. So yeah. Yeah, I have some architectural issues with that lab, but yeah. So basically, we have a. Well, let me show you. We're going to be doing this here. Hey, look, class methods. So when we, so there, so there's the setting up the class methods and initializing stuff in the class, and then there's calling the class methods or looking at the stuff in the class. I think that might be where we're getting hung up there. So let me work through this example and then see if that clears anything up or makes it more confusing. We'll see.
Yeah, and because like I did the lab, like I didn't have much trouble with it. I guess I'm just trying to get more philosophical of like
Yeah,
why this and not just instance methods.
yeah. You know how I hate philosophy. Uh, cool. So um, let's work through the stuff that's here. So and maybe this will get to what you're talking about even sooner than we thought. So we're going to have a pet class. And I'm just going to run this straight, I think. We're going to have a pet class. Uh, let's make a total pets class attribute. And so we don't need to do anything special here. We are just defining it inside the class. So it belongs to the class. Again, other languages have different syntaxes for this. Python's is pretty, it is deceptively straightforward, I think. It looks a lot like other not special stuff. So it can be maybe unintuitive to figure out exactly why this does this here instead of somewhere else, but we'll walk through it. So I'm going to define a class attribute called total pets. I'm going to set it to 0. Bam, just did it. So because this variable is inside this class, it is attached to the class. So if I did, no, this is gonna mess me up, is it? Let's do this. You know, if I just did, print, I'm gonna set this to a different number, 24. If I just did print pet, so if I print pet, it's gonna give us our class. That is a class. If we make a new pet, dog equals new pet, print dog, that should give us an instance pet object. And so now if we want to see what the number of total pets is, that is attached to the class. So we can just say total pets there. So kind of unintuitively, let's just verify we're not lying. Great. Unintuitively, a class is also an object. So a class is a thing that exists clearly, right? Here's a class object. So a class is actually as concrete as things get in programming, a concrete thing that we can attach stuff to. And so we're attaching a value to it, a variable, a property. And I imagine we can just say, pet, total pets equals whatever. That's not a number. If we look at it again, we can get and set those just the same as we could set instance variables, except the object that we're getting and setting those on is the class itself. The class is an object. It's just a different kind of object. Is that more or less confusing?
No, that's great. I was like ignoring all these variables I'd set at the top.
Mm-hmm.
That makes sense. Like, okay, I set them at the class level and then use a class method as opposed to setting it at the instance level and using an instance method. So that puts it all together for me.
Yeah, and once you make that shift from like class just being a like expression, like setting a function or whatever, or bad example here, but um, it's not just like, oh, here's syntax to say from here on out is going to be in this named class. Like it is actually creating a concrete object in your code that is that class. And when you run that object, it's going to give you instances of that object. But you can hang stuff on it. I wonder, this is true in some other languages. I don't know if it's true in Python. So if we do Xord, if we set this to something, gotcha. I wonder if it's going to let me create that on the class if we didn't define it. I honestly don't know if it lets you do that. You can definitely do that with JavaScript objects. You can definitely do it with dictionaries here. Um, does it only let you modify declared variables in there, or does it just treat it like a namespace? Let's find out. Yeah, so you can set arbitrary properties. You can set arbitrary class variables on a class. Cool, 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 cool. That's really interesting. All right. Yeah, so it's literally like any other object. You can smack whatever you want in it. That's really interesting. I did not think that was going to work. But that makes sense because that's probably how the decorator to do class methods works. So that would make sense. It would have to. Hey, we did that. Cool. What happens with our instances when we add a class attribute? Nothing, because it's not that is not uh, the instance. Let's so um, these are the what you call these are the initializer for our objects. The objects are separate from the class itself, so changing those is not going to change anything about the class attribute at all. Cool. Let me what do I do from here? Well, let's see. Create a update the class attribute whenever an instance is initialized. Yeah, let's do that. Cool. So I think do I want to add another? Yeah, let's add another method here. So this is where we're gonna use and normally you put the class methods up top. Um, Different places have different conventions for this stuff. So if I want to increase the total pets, um, increment, increment pets. Cool. I would just say, total pets equals total pets plus one. I probably want to do it pet total pets plus equals one. So if I run this function, I would have to run it right now on an instance because it's just a regular instance method now. We can turn it into a class method by doing class method. So now instead of being, so we have dog equals a new pet. It's going to be carrier, and it's cool. So this is going to be our dog. Right now, if we call, let's do print pets, total pets. If we say, well, we can't call it on dog because it's not a instance method, but we can call it on pet. So we call it pet increment pets, and we do this again. That should actually let me do this up here. Increments. Given. Yep, that's what we want. There we go. In fact, instead of explicitly saying pets, I could say class there. So now if we run this again, great. So we are printing out the number of total pets. It is 24. We're creating a new pet, and then we're manually incrementing the pets here. And then when we look at total pets again, it is the new number. So I can move this here into our init function. So after it's created, I can say pets, increment pets, pet increment pets. So I don't need to do it out here. I can just, whenever I create a dog or whatever, it will automatically, yeah, it works. It will automatically call that class method. And I think you're going to see stuff like this a lot when we're talking about, especially like aggregate classes, like a playlist with songs. Every time we create a new song, we're going to want it. I'm sorry, jukebox, I guess. I don't know. Every time we create a new song, we want to add it to the list of all the songs that have been created, so we can get a count off of that, or pick a random song or whatever. Oh, hey, I did that already. Look at that. Cool. And so that's how we use class variables or properties, attributes, different, they can call different things. Class properties, class attributes. You can just declare them by declaring them in a class like that. You don't need to do a self or anything. Class methods, just like defining a regular method, but instead of taking self, it takes the class. We don't use the word class in there because that is a reserved word. And then you can act on that class's class properties as well. And of course, you can do that down here too. If I could say, pet total pets plus, not plus equals 1 here. Because Python doesn't have a plus or minus for some reason. Yeah, so we can alter class methods inside of that. We can call class methods. It's real open and loosey goosey, like we saw. We can just add arbitrary things. So basically, what this is doing is class method is a function that is going to take this function here. It's going to wrap it in some code that says, hey, find out the class that we're in, create a function that takes that class, and then calls the thing with that. So it's probably pretty light wrapper, but this is how and this is why we went through all of that decorator stuff, just to kind of like see under the hood how that works. Because without that, it just kind of looks like magic. You can definitely learn and use decorators without knowing how they work under the hood. That's fine, but it's nice to know A, how they work, and then B, you can write your own if you need to. We're going to be using this here. We're going to be using it in Flask. They're all over the place, and it's a syntax that looks different and is easy to get tripped up on if you're not aware of exactly what it looks like. Yeah, I'm not going to worry about that. Yeah. Questions about class methods? Or if you had questions before, does this clarify what you were looking at? All right. Let's do this. I think I have yeah, I have a cat. Look at that. I'm gonna start using this debug script here. Yeah, we did that. So we're gonna import these classes. Is there an owner class? Look at that. Owner class is already written out for us. It does some things. Takes first name, last name, age, count, does some calculator stuff. Great. Don't need to worry about that right now. So we're going to be importing these modules that we've created. Each of these files is a module, basically, kind of like modules in JavaScript. Syntax is a little bit different. So we can say just import everything from these. So if we import from pet, we're going to bring in all the stuff that we actually, you know what, I'm going to put that, where is it? Yeah. It's going to import our class from there. This is an incident method. Yes, great. Boom. Probably going to be using that. Cool. So we're going to be importing pet. We're going to be importing owner, which has stuff built out for us. And we're going to create a cat class that does stuff. And class cat is going to inherit from or be a subclass of pet, because that just makes sense. So let's look at what that looks like. first of all, let me make sure that the debug thing doesn't explode. Yeah, great. Doesn't do anything. Good. That's what I want. Sweet. So let's talk about subclassing. So basically what happens when we subclass is we have a parent class, pet, say. When we make a child of this class, a subclass of this class, something that inherits from this class, it basically gets access to all of its stuff. So if we make a cat and just say inherit from, and the way we say it, I don't need that. Import, yeah, we're gonna need to import pet before we do it. We're gonna need to import pet. Boop, get back there. Import pet from libpet. I did that. Oh, that's gonna be in the back one. Oh, it's getting back there. Cool, yeah. Because we're importing down here, I don't think we need to import here. Let us verify. So let's make a class, call it cat. And to tell it that we're going to inherit, we just need to pass it that class. Because remember, a class is just an object that we can import here. I think we do need to actually import it from there. Yeah, cool. So I'm going to say from, I think since we're just here, I can just say cat, right? Yeah, from cat import, or sorry, from pet import pet. Yeah, that works. Great. I think this should not blow up. It is going to blow up. No module name pet. I disagree. Definitely disagree there. Oh, that's in this one here. Line 5 from lib cat import. Why is that blowing up? Good to check early. No module named pet. And cat. Okay. I disagree. But do we need to say lib here? Yeah, great. Okay, cool. So the stuff it's importing from is from the namespace of the entire module. Okay, great. This always is always confounding. You will have trouble with it, and you just need to experiment and find the right way to do it. Great. So we have a cat here. We're importing it here. Yeah, I'm just gonna say let's print out these two things. We're gonna print out pet. I'm gonna print out cat. These are the classes. What does that look like? That is a class, and that is a class. It doesn't tell us what it inherits from. This is where documentation is good, but we're just gonna go ahead and do that. So, is there in Python? I think there is. Nope. Nope. Is it called prototype? Nope. Come on. There's probably some way to tell what parent class is, but I'm not concerned about that right now. Cool. So let's make our init here so we can initialize it with some stuff, right? It's going to take self at least. And let's add some stuff. Why is this red? Who knows? Let's take in a name, age, breed, temperament. Is it an indoor cat? Oh, look, we're adding stuff to it. So we're extending all of these. So where we are extending this class pet. And so we can say, self name equals name and all that stuff. But all this work is already done for us in pet, and it would be a shame to have to type it over again. So we could, copy paste that and then add one for indoor outdoor, and it would work great. But if we have a bunch of different kinds of pets that inherit from pets, I don't want to have to remember and or type that every time. So we can access the parent class from in here with a little thing called super. Super is a function. It is a function that returns the parent class. In fact, if we do here, so we're creating some new pets here. I'm gonna get rid of that for now and get rid of these for now. I'm gonna say Sam is a new cat, and it takes a bunch of things. I'm gonna take Sam. It takes a number. It takes it's a cat. It's fine. And so this is our Sam here. That should blow up. Great. We can print out Sam and get our. It's a cat. It's a cat object there. Great. That's what we want. So in our initializer here, we can set all these things, but there's a function called super. I'm just going to show you what super returns. I believe it's a function. Let's find out. Hey, look at that. Super is cat class cat, which inherits from our pet. And that means that we can call the initializer from our parent class here. So if I do super, I can call the init method of that and then pass it in all the stuff that I got from here. And then I would have to manually add indoor here because we're extending it. So basically, instead of doing all the work, and we don't know is, oh yeah, look, it is also doing some extra stuff here. It is calling increment pets, which is interesting. So let's see what happens before and after if this actually does what we think it should do, or if we need to add something to our cat class. Cat total pets. Total pets, yeah. And let's just copy that down here. Oops. So now we should print that probably. Let's try this again. Print that. Great. So now we're going to print the total cats before and after we create. A, will it explode? B, will it do what we think? Hey, look at that. It did the thing that we think it's doing. So it is inheriting not only the init method, but it also inherits this here. What happens if we say pets, total pets? And is that going to change the number of total pets there? Interesting. Yeah, there we go. Cool. I think those numbers are going to be the same. Yes, they are. Let's try one more thing just to see if they're connected. I'm going to create a new pet. Here's Cookie. Let's use Cookie. I'm going to do Cookie, and then I'm going to print out. Do a print here. Here. I'm going to print out these boys here and see if creating a new pet changes it in the superclass and the subclass. I have my theories, but let's see what it does. Look at that. So because it is calling the init from pet when it creates a new cat, it is actually incrementing the number of total pets in the pet class, not in the cat class. So when we create a new pet of some kind, total pets is still going to increment. So keep that in mind when you're creating class variables that are going to be used by inherited classes. This is usually what you want. Sometimes it might be confusing though. So that does that. I'm happy about all that. Any questions about the basic inheritance stuff here? Cool. Let's get rid of Sam. Let's use Grace. All right. Yeah, let's make our owners here. Why not? That's not what I wanted. They should just do nothing. Great, exactly what we want. So what else do we want to look at here? We did that. Cool. So this is how you can extend your parent classes and by using them to set up the basic stuff and then adding stuff to it. So if we, if we just did our define name, age, breed, temperament here manually, we would have missed out on that increment part. So using super is generally what you want to do, both for ease and for consistency. Let's create a method unique to the cat subclass called talk, which returns meow. Easy. So this is going to be just a regular class method. Talk. And it just prints out meow or returns the string meow. We want to print. Let's put the name in here. It's going to take self. Great. So now if we look over here and say Grace talk, that should exist there. And we get our talk. Meow. Cool. Can Cookie talk? No, only cats can talk, not other pets. Yeah, which is what we expect because this is defined in the subclass and not in the parent class. Why would I want to do that? Oh, I guess I want to print the indoor. Cool. Do I want to? Yeah, let's do this. So in our pet class, we're going to extend this function using super. So right now it does that. So it's going to print the name, age, breed, temperament in that order. We also want it to print the indoor status for. I don't think we need these guys right now. So if we do, cookie print pet details, we should get all that stuff. And if we do the same thing for Grace, we'll get the same stuff minus the outdoor attribute. Yeah, great. I don't even need that. Cool. So we're getting that. We're getting that. We want to add the indoor attribute to this one. And hey, we can just call super again. That's cool. So we can say print pet details. This is, hey, look at that. It does that automatically for me. So what this is called is overriding a method, a class method, instance method. We're overriding this method by calling it the same thing, but that means we're redefining it. So we could have it do something completely different here. We could just have it say, I don't care about your details, meow. But we do care about the details. So don't need to return it, but we are going to call it. We're going to call super, which is our pet class, print pet details, which gives us this. And we're also going to just let's just print. I can just format that like that, right? Endure. Let's see if that works. Down there. I wonder if I put it in the same kind of format like that, if it'll, if I do extra one there. Oh, right. Helpful. 2, 3, 1, 2, 3. That should do, right? What are we doing wrong there?
Is
Closing
it just
parentheses.
single quotes and not backticks?
Yeah,
Python doesn't like backticks.
Python doesn't like backticks. There we go. Yeah, no, no, much better. But normally stuff like this, we wouldn't be printing stuff, we'd be returning stuff. But this basically gets the idea. We are calling the print details of the parent, and we can extend that just like we extended the init here. So yeah, in a real thing, you'd probably be returning stuff instead of just printing stuff directly, but this is what we got here. Cool. And that's so that's decorators, that's class properties, that's class methods, that's inheritance, and extending inherited classes. I think that's enough. This pretty much covers everything that you're going to use as far as object-oriented Python goes. Am I missing anything? I don't think so. Nothing comes to mind. Yeah, so this is what you'll be doing from here on out, using this stuff and extending it to do database and whatnot. Oh, the one thing that we will talk about later is the composition stuff. So, which is not that difficult, right? It's just saying, oh, if we have an owner, that owner might have bets. That's going to be an empty array. We add stuff onto that, just like you were doing, or saying with the songs before. But it's just a use of the stuff we just learned. It's just using class properties and methods to alter them, just like we're doing with pets here. Only instead of incrementing thing, we would be adding it to an array. Which, if you've been doing the exercises, you've probably already done. Yeah, so that's my high level overview of all of the object-oriented stuff, the basics in Python. What questions do you have for me? And even questions of stuff I didn't cover that you're curious about. Are we good? Cool. Sweet. So I think that's what we've got here. Keep plugging away. There should be some more fun Python stuff in Learn to play with. So play with that at your leisure. We'll be talking about SQL stuff tomorrow, so hit those up if you want to get a head start. Otherwise, final call for questions. Comments, thoughts? Great. Awesome. Thanks for hanging out. I will post this in the usual places. And yeah, I'll catch you later on.